Good morning student, welcome back to my channel, The Science Station. Through this channel, I will provide you and explain you BTech first year applied physics notes and engineering chemistry notes. So please be with me and like, share, comment and subscribe my channel. Okay, let's start today's session. In yesterday's session or in previous video, we describe or we derive this expression, that is the Planck radiation law in terms of wavelength, that is E lambda equal to h 8 pi hc upon lambda to the power 5 e to the power h nu upon kt minus 1. Till here we derived in previous video. Now today's video. Sometimes question comes like this: Rayleigh-Jeans law from Planck's theory, and is the Rayleigh-Jeans law valid for all wavelengths? One question here. This question contains two questions. First question here. Second, explain the Wien's displacement law. Now, first we have Rayleigh-Jeans law from the Planck's law. Rayleigh-Jeans law is the classical law which measures the intensity of radiation emitted by a black body. This is obtained by counting number of standing wave mode in an enclosure. This law holds only at lower frequency. Only at lower frequency. Again, I am stressing here lower frequency, that is for higher wavelength. We have lower frequency means we have higher wavelength. This is the Rayleigh-Jeans law according to Planck's law of radiation. Now derivation. The expression for Planck's law of black body radiation in terms of wavelength is given by this: E lambda d lambda equal to 8 pi hc d lambda lambda to the power 4 hc lambda upon lambda kt minus 1. Here we have h nu. We are keeping the value of h nu, that is c upon where nu frequency equal to speed upon wavelength. So this is our equation number 1. As the Rayleigh-Jeans law is applicable for lower frequency or a higher wavelength, let's see what happened. Only for higher wavelength or long wavelength reason lambda into t is greater than 1. अगर wavelength ज़्यादा होगा, it is pretty obvious इसका value 1 से ज़्यादा होगा. If it is greater than 1, then hc upon lambda kt less than 1. इसका value ज़्यादा है, then इसका value कम होगा. Now e to the power hc upon lambda kbt. Sometimes we write kb or k. They are Boltzmann's constant. E to the power means k is also Boltzmann's constant. Or sometimes we write kb. Both are same. So e to the power hc lambda kbt, can we write this expression 1 plus hc upon lambda kt dash dash dash. This value contains very less value, so square भी बहुत कम हो जाएगा. We are summarized here. E to the power hc lambda kbt equal to 1 plus hc upon lambda kbt. That is equation number 2. This is the equation number 2. Now on substituting the value of this into equation number 1, our equation number 1 is this, that is E lambda. Our equation number 1 is E lambda d lambda equal to 8 pi hc upon lambda to the power 5 e to the power hc kt minus 1 d lambda. This is our equation number 1. From equation number 2, we get the value of e to the power hc upon lambda kt equal to 1 plus hc upon lambda kb. Now putting this value into equation number 1, we get E lambda d lambda equal to 8 pi hc d lambda upon lambda to the power 5 1 plus hc upon lambda kt minus 1. Minus 1 cancel here. hc cancel. Okay, I will write here 8 pi hc d lambda lambda to the power 5 hc upon lambda kt. ये ऊपर चला जाएगा. We have 8 pi hc d lambda lambda to the power 5 lambda kt. hc this is lambda to the power 4. So finally we get 8 lambda kt lambda to the power 4 d lambda equal to e lambda d lambda. Okay, or we get e lambda d lambda kt lambda to the power minus 4 d lambda. This is the Rayleigh-Jeans law using Planck's equation. Just see. Same thing I explained you, substituting the value, and by cutting this we get this. From this law it is pretty obvious that for higher wavelength intensity will be, for this law indicates the relation between intensity and wavelength. Okay, now this is the Rayleigh-Jeans law using Planck's law. Now Wien's law. The product of wavelength lambda corresponding to the maximum radiant energy and the temperature is a constant. Lambda t equals to constant, that is a Wien's law. Now expression, as the Wien's law is applied for the short wavelength region. Rayleigh-Jeans law is applied for long wavelength region. This law is applied for short wavelength region. Short wavelength region means lambda t is less than 1. लैम्डा की वैल्यू फॉर शॉर्ट वेवलेंथ, लैम्डा की वैल्यू जो होगा फॉर शॉर्ट वेवलेंथ, हमारा जो लैम्डा का वैल्यू है दैट इज़ लेस देन 1 का वैल्यू ज़्यादा होगा. देन इट इज़ प्रिटी ऑब्वियस कि इसका वैल्यू बड़ा होगा. देन इसका वैल्यू बड़ा है, दिस इज़ 1. सो -1 इज़ इक्वल टू दिस. अगर वैल्यू 1 से बहुत बड़ा है, वी सब्ट्रैक्ट 1 फ्रॉम दैट क्वांटिटी, डजेंट मैटर. नाउ वी नो दैट Planck's law, we have this equation, putting the value of this is this one. Okay, so we get this. Nothing happened. इन सबको ऊपर ले आए हैं, इसको भी ऊपर ले आए हैं, डिनोमिनेटर बिकम न्यूमरेटर, पावर बिकम नेगेटिव. ओके, द अबव इक्वेशन रिप्रेजेंट द Wien's law using Planck's law. First, here we have this equation for the Wien's law, Rayleigh-Jeans law, and this is for Rayleigh-Jeans law using Planck's law of radiation, and this is the Wien's law. Now limitation. What is the limitation? First, it is restricted to the lower wavelength. For the longer wavelength it deviates from the experimental value, means this is only for lower wavelength region. Longer wavelength में it will not work. Second, it could not explain the energy distribution in black body radiation spectrum shown by the experimental value. See, this law is working for only lower wavelength, so it is for higher wavelength spectrum we cannot explain. So this law is failed for, so this is not working for high wavelength. Now assumptions of Planck's law of radiation. First, the black body radiator contains simple harmonic oscillator of possible frequencies. Second one, the oscillator cannot emit or absorb energy continuously. As I told you before, it cannot absorb or cannot emit the energy. This is a contrary to electromagnetic theory, which allows us a continuous emission or absorption of energy. We have first harmonic contains simple harmonic oscillator. Second one, it is contradictory to the electromagnetic theory. This allows simple, this is here we don't have continuous oscillation. Third one, emission or absorption of energy takes place in discrete amount, that is energy oscillator is quantized. In general, for any oscillator frequency nu, the possible value of energy can be defined by E equal to h nu and positive integer h Planck's constant. Here we have the Planck's radiation law, assumption, all things. So tomorrow in next session we will discuss photoelectric effect, which is very important. This effect will be useful in next unit, that is LED. To next session I will explain all photoelectric effect. Till there, be with me. Please like, comment, share and subscribe my channel, The Science Station. Thank you so much.